Right, so I'm just going to do a recap of everything we did. We are essentially done. The only thing we need to do again is chain rule. So okay, that's what I'm gonna cover today. And remember that we have to do connected rates of change, right? So that's one thing we need to look at. Connected rates of change. All right, so Kamaya, do you understand that the whole purpose of differentiation is to see the rate at which one thing is changing with respect to the other thing? Like think about it. dy dx, you're comparing the rate of change of y to x. So essentially, Kamaya, if I change x, how much is y changing by? That's the whole purpose of differentiation. Rates of change.
Yeah, sure.
So like let me give you an example, right? Guys, let me give you a practical example. Let's just say you have a cup here, right? And you have a pipe here. Let's just say the pipe have a problem and the pipe is dripping some water. As as time progresses, what's gonna happen to the volume level of that cylinder? It's gonna happen.
It's gonna increase.
Exactly. So the volume is changing with respect to the, tell me guys, the volume is changing with respect to
Respective time.
exactly. So that's something we could find dvdt, the change in volume with respect to time. All right, cool. Could you all tell me something that would also change with respect to time? So the volume would change. What else would change, guys? There's something else that would change. As water keep filling, what would change? I want you all to figure it out.
So the space in the container
Mm.
increase.
Pressure.
The pressure, you're not wrong, but we typically wouldn't look at that. The pressure because of fluids, P is equal to H rho G, but you wouldn't consider that much. It's something have something obvious you're missing out on. It's something that,
Is the container that the water coming from, like the pipe?
what do you mean?
Like the pipe connected to some kind of
Okay, no, we just
source of
we
water.
just considering that you're considering the cylinder. So the volume of the
Okay.
cylinder is gonna change, water's gonna fill up, and okay, well, other than volume, what's gonna increase?
Steady height.
Yes, Sachin, the height. A little come on, Jenna, Nathaniel, Zachary. Let's see the height. As the water increases, the height is gonna increase, yeah? So I think I'll
Yeah,
realize
sure.
something. Everything is gonna change with respect to what? Everything changing with respect to what?
Time.
The volume.
Time.
Time. So dH dt. And something that you might not see. I have a question for you guys. When the height changes, what would change as a result? Let me see if I can figure this one out. If the height changes, what changes of the cylinder? Let's see if I can figure this out. Um, Zachary, what does a higher level imply? Like, what does a higher level of water imply?
That the container almost full.
It's almost full, right? So we talking about the capacity. So we
Yes.
talking about what? We talking about what do you call the amount of water in a container? Thomas Zachary, what do you call the amount of volume in a oh God, I'll tell you the answer.
Well, it
I, I,
says
I, I
volume.
I just hate myself for that all. I have no idea. Like I go ask a student a question and somehow I go say the answer and they can I don't understand how that's work. But yeah.
Yes.
Yeah, Zachary, the volume. So as the height changes, what's gonna change?
The volume.
Right. So how would I write that in derivative notation? So Zachary, you
Says
tell me, yeah,
dV
dv.
over the H.
All right, cool. Is there anything here you all don't understand? Jenna, talk to me. Is there anything here that you practically don't understand? It makes sense.
No, sir. I understand.
So Jenna, as the height increases, what would increase?
The
Tell me, Jenna.
height.
Like, no. You hear what I just asked you, right? Ask you if the height increases, what would increase? And you tell me the height.
Sorry.
Ah, ah.
The volume, sorry.
Yes, the volume.
Yeah.
Guys, I want you all to compare these two instances, right? Let's just say the water is at this level. Some time passes by and the water is now at this level. So the height changed, but what changed as well? Tell me, Jenna.
The volume.
Exactly. So, guys, if you think about it, we have these three rates of change. Do you all understand that? We have these three rates of change.
Yes, sir.
Okay, cool. So we have dVdt because the volume will change with respect to time. We have dHdt, the height will change with respect to time. And we have dVdh. So let me show you guys something. Notice that the topic is connected rates of change. So like, let me show you some magic, right? Let's just say you wanted to find dVdh. Well, if I wanted to find dVdh, look at this, look at this carefully. Nathaniel, I could say dVdt multiply by um dHdt. Not sure if you're seeing that. So I could find dVdh using those two. So Nathaniel, watch. Nathaniel, if we have dVdt here,
Yes, sir.
and if I multiply that by the reciprocal of dHdt, that'll be dTdh. Why am I doing this, Nathaniel? Well, watch. We got only dTs.
We'll cancel.
And that'll be equivalent to dVdh. So that's the whole concept of connected rates of change. You're using two different rates of change and you're multiplying them to find another rate of change. So it's connected. That's the whole concept we'll be looking at today. So let me jump straight into that question. A past paper question. Jenna, I don't know how you have so much energy, like I low-key feeling tired. I'm not gonna lie.
That's so me too. I just like the ad maths is yeah.
It is getting just get excited or something. Admas is fun enough.
Yeah.
That's interesting.
It is.
Like I prefer
Because
Admas
my
over
teacher
regular
taught
maths.
this.
Yes, it was gonna say.
Well, nah. Absolutely. But my teacher taught rates of change and I didn't understand anything. And it was like, because I'm not in physics, and this kind of is similar to physics, I was like just totally lost. And I would ask questions to try and figure it out, but like I still wouldn't fully get it, like what I'm doing. So like
Okay.
you explaining everything in depth is like actually making me realize, oh, so that's what that's for.
Mm-hmm. Yeah, so it's like
So I'm excited to like see more.
that's good. That's good. So I hope all you understand. Like it's real simple, like until I see the example just now with how like okay, so when we look at a practical example, like a scenario, we're just asking ourselves, what are the things changing here? And with respect to what? You analyze those and you could use two to multiply them to get one other rate of change. That's all. So I think by now you guys would realize that most things change with respect to what? What do most things
Time.
change? Yeah, most things change with respect to time. Do you all understand that?
Yes,
Yes.
sir.
I want to let it record it. Somebody record like a voice and I go and pull a Rizzler on Mrs. Math Vibes. All I have the recording. Like somebody
So you're recording the video.
that small thing. Just like on your group chat. Just like press record and they'll tell me when you press record. They tell me, right?
That's not sad. That's this.
So I'm
Oh,
recording
you're not gonna just okay.
Who recording?
me.
All right. So most things change with respect to time, but my love for Mrs. Math Vibes remains constant. That's guaranteed. I send that in the group chat.
Ooh.
Tough.
So, I'm the Rizzler, you know. I'm the Rizzler. Nathaniel, I'll teach you something, son. Joking.
Nah, sir. I don't need help with ad maths. I don't need help with that.
All right, all right. No problem. All right. Come on. How does his lines just work? Like, I don't know. Is Nathaniel a certified Rizzler? Or what do you say?
Sometimes.
Sometimes. All right. Well, Nathaniel, I guess you don't need my help.
Yeah.
I guess not. All right. So, Jenna, read the question for me.
Water is poured into a cylindrical container of radius 15 centimeters. The height of the water increases at a rate of 2 centimeters per second. Given that the formula for the volume of a cylinder is pi r squared height, determine the rate of increase of the volume of water in a container in terms of pi.
Right. Do you all want to see this like a interactive model of this example, like see it in real life?
So
Um,
Yes, sir.
I'll do that. Give me a
Yes, sir.
second. Give me a second. I can use Claude. Can you create a simulation of this? Give me a moment. Claude takes a little while, so I'll explain the question and then I will show you all what is actually happening. All right. So let's analyze the question first, right? So Jenna, they're saying water is poured into a cylindrical container, right?
Yes, sir.
So I'm gonna have a cylindrical container here. And what am I pouring into it?
Water.
Right. So let's look at what's changing, right? We need to look at what's changing first. Okay, so first things first, Jenna. Would you say that the radius of the cylinder is changing? Would you say that's changing?
No, sir.
How about the rest of you guys? Guys, do you all think the radius of the cylinder will ever change?
No, sir.
no, sir.
No. Cool. So you want to identify some things that will remain constant, okay? The radius, that's something that will never change. Right, next thing, Jenna. As time passes by, what's going to increase?
The volume.
Right, so the volume changes with respect to time. So put that, so the first rate of change is dV/dt. What's another rate of change you could see?
Um, dVdh.
Oh wait, cool, this is real cool. Oh, that's bad, that's bad. Yeah. Okay, sure, let's just know. Like got me mind blown. Yeah, like got me mind blown. Oh good, that bad, that bad, that bad. Yeah, yeah, okay, okay. Yeah. Come on a second. All right, let me continue. I'll show you the example just now. Yeah, dV/dt. And what else, Jenna?
Um, dVdh.
Right, dV/dt. So the volume will change with respect to the height, right? What else would change?
Um, dH/dt.
Right, the height would change with respect to the
The
time. Yeah.
height with respect to, yeah.
So we've identified what the scenario is. We've identified three main rates of change. I think that's enough to figure out the question. So any question they're telling us that the radius is what? What's the radius?
15 centimeters.
Right, so that's a constant. Okay, guys, that is a constant. Don't let it confuse you. That's a constant. That's constant. They're saying the height of the water increases at a rate of 2 centimeters per second. So Jenna, let's understand our line. The height of the water increases at a rate of 2 centimeters per second. Which rate of change is that? Is that dV/dt? Is that dV/dh, dH/dt? What's that?
Um, dH/dt.
How about the rest of you guys? You all agree? So the height of the water increases at a rate of 2 centimeters per second. Which rate of change do you all think that is?
EHDT.
Yes, sir.
Everybody agree? Okay, cool. So we know that dHdt is equal to 2 centimeters per second. And Jenna, you were saying that this is like physics. It is physics. Watch out this. Look at this, right? Jenna, centimeters per second. Centimeters per second means centimeter over second, right?
Yes.
What do you measure in centimeters?
Wait, no.
Tell me, Jenna, what do you measure in centimeters?
Measure, like
What do you measure in centimeters?
when
In
you say
terms,
what, like
in terms of this example, what could you measure in terms of centimeters?
the height,
The height, and what would you measure in seconds?
the time, like, yeah.
Let's see in that.
Oh,
The units, sell it out, the units to sell it out. Look at that. Like centimeters per second means height over time. Well, let's see what I'm saying.
yes, sir.
Yes, sir.
Right, so cool. Please use a hack. That's a very good hack. The unit sells it out. Then they're saying, given that the formula for the volume of a cylinder is pi r squared h, determine the rate of increase of the volume of water in the container in terms of pi. So here's what, guys. They give us the formula for volume of a cylinder. We should probably write that down. So they're telling us V is equal to pi r squared h. Before we move on, guys, what's a constant they give us? What's the constant? What's constant on this?
The radius.
Right, we should plug that in one time. The radius was 15, so that's going to be 15 squared each. What is 15 squared?
225.
So pi by 225 by each. I mean, if you're okay with that.
Yes, sir.
Cool. So that's the volume. So the volume is just 225 pi each. Nice. And we need to figure out what they want us to answer, right? They say determine the rate of increase of the volume. What do you think is that? Rate of increase of volume. Which one do you think is that? dVdt, dVdh, which one is that? Tell me, Jenna. Jenna, which one is that?
So you could repeat the question, sorry.
The question is asking us to determine the rate of increase of the volume. Which rate of change is that? Is that dVdt? Is that dVdh?
I would say dVdt.
Exactly. Guys, anytime you see rate,
Wait, no.
why you say no? Like, okay, anytime you see rate,
Sorry.
anytime you all see rate, what does that include? Rate. We always measure rate with respect to what?
Time.
Time. So Jenna, when you see rate of increase of volume, in your head, you should already be thinking time and volume.
Okay.
You understand that or no?
Yes, sir.
I have a question, guys. Would time change with respect to volume?
No, sir.
Come on, if you fill water in a glass, would that change the time continuum? Would that change the space-time continuum?
Sir.
No. So how could time change with respect to volume? That don't make sense. The volume could change with respect to time, because as time passes by, the volume could either increase or decrease. Right? So Jenna, they want us to find what? What do they want we to find?
The increase of the volume. So dt dv.
dt dv? Nah, it's never, dt is
Sorry.
never on top. Never on top.
Oh,
Everything changes with respect to time. So it's never on top. Think
okay.
about it, Jenna. Jenna, if you write dt dv, right? Then here what you telling me. You telling me that time changes with respect to volume. I will just soak in that for a bit.
Oh,
Does volume affect time?
no, sir.
Think about it. If you fill a cup and you empty it, will you go back in time?
No.
No. So how could volume affect time, right?
Okay.
So DT don't make any sense. It's dV/dt. So do you
Yes.
understand do you understand they want us to find dV/dt?
Yes, sir.
Okay, cool. That's what they want me to find. So this is what we want to find. Let me show you how easy that is, right? So stay with me. Stay with me, guys. We want to find dV/dt. Now, if I want to find dV/dt, and I know it's going to be a product, what's going to go on top here? Like what's going to go on top here for sure? Anybody want to tell me, like, it's going to be a product, right? What has to come on top here, and what has to be in the bottom here for sure?
DT.
dV.
dV had to come here, and Jenna, what would have to come here for sure?
DH, DT.
Well, dt, right?
Oh, yeah.
Now, here's the thing, guys. Here's the thing. Stay with me. We are trying to figure out what variable or what parameter could exist there and there. So we're looking for the same thing, right, Kamaya? We're looking for the same thing so it would cancel off. You understand?
Yes, sir.
So now we're gonna look at the tree rates that change. What other parameter we have? We have volume, we have time. What's the other parameter?
Height.
Height, yes. So it's gonna be dV over what?
DH.
Right? And it's gonna be what over dt?
DH over DT.
Do you understand that? Yes or no?
Yes, sir.
Jenna,
So,
Kamaya, Nathaniel, Sachin, I'm gonna follow confused.
No, sir.
no, sir.
Hey, if you have anything confused, no, tell me, you know. Jenna, like, you understand everything so far or no?
Yes, sir. I think, yeah.
All right, so Jenna, how did I figure out what rates have changed after multiply to get dV/dt? Explain that to me.
Well, we know we want something to cancel off. So obviously we'll start with DV
Right, so
and
start with dV, and what will I put here?
and DT because it's the most common one, I think.
Yeah, because you want to get dV/dt, right?
Yeah.
And
And well, you'll find something that can cancel off, which is DH.
right, so we can put dH here. This is one of my favorite topics in differentiation, and I love this. And so now, Jenna, we're gonna look at what we have, right? Which one do we have so far? Which one was given to us?
So, DH and DT.
Not dH and dt, that's dH/dt. That's the change in height with respect to
D.
time. So if you're reading it, Jenna,
So
this is a change in height with respect to time. Say it.
the change in height with respect to time.
Say this one for me.
Change in volume with respect to height.
Cool. So here what? Does everybody agree that we already have this? We already have this. I'm gonna know.
Yes, sir.
What's the other thing we have to find for now?
dV with dVdH.
dV/dH, right? Let me ask you all a question. dV/dH implies that we differentiated volume with respect to height. Do we have a formula for volume that contains height?
Yes, sir.
Right, it's right here. So we're going to differentiate that. We're going to differentiate V with respect to what?
Height.
Height. Yes, and what would you get, guys?
pi.
Yep, 225 pi. I feel like you guys are thinking it. Jenna, if I tell you to differentiate 5x, what you go tell me?
5.
Exactly. So if I tell it to differentiate dV with respect to h, um, would not just be 225 pi?
Yes, sir.
Are you sure they understand that? Zachary, Kamaya, Nathaniel.
I don't really fully understand.
All right, so Nathaniel, if I ask you to differentiate, say 7x, where you get on?
7.
Okay. If I ask you to differentiate, say 225h, where you get on?
225.
Okay, if I tell you to differentiate 225 pi h, where you get on?
Well, 225 pi.
Yeah.
Yeah.
Yeah, I don't understand. Pi is a constant, pi is not a variable. H is a variable.
Yeah.
You understand now?
I understand, sir.
All right, cool. Nice. So we have the VDH. So here what? I have I have all of the pieces of the puzzle now. So it's really simple. Jenna, what's the VDH? Tell me, Jenna, what's the VDH?
The change in volume with respect to height.
Right, but what did we find it to be? What did we
Oh,
find
sorry,
that to be?
2 centimeters per second.
No,
Wait, sorry, no, 225 pi. I was
225
wrong
pi,
there.
right? 225 pi. And what did we find the HDT to be?
2 centimeters per second.
Right, so you just write two, right? We're gonna leave out the units for now.
Okay.
And they said to leave our answer in terms of pi. So what is 225 pi by 2? What is 225 by 2, guys? Leave your answer in terms of pi, yeah? Leave your answer in terms of pi.
450.
Right, so that'll be 450 pi. Now we need to put our units. So our question, guys, what would we measure volume with respect to? Jenna, I would advise you to look at the other units in the question. They were using centimeters to measure our length. So if centimeters is for our length, what would the unit for volume be?
Centimeters.
No. Mm. All right, Jenna. If I give you a cube, right? I give you a cube. How would you find the volume of a cube? I tell you, like each side is like
Side by side by side.
exactly side by side by side. So that'll be centimeter by centimeter by centimeter. So what is that? What is centimeter by centimeter by centimeter?
A cube.
Is it?
A cube. When you say like what is like what do you mean?
Okay, so centimeter by centimeter by centimeter is centimeter cube. So we measure volume in cubic. So if we're measuring a length in centimeters, then volume would be centimeters cube.
Oh,
I don't really fully understand that. Let me show you. Imagine you have a cube here, right? And each dimension was 1. How would you find... Okay, so each dimension is 1 centimeter, right? 1 centimeter, 1 centimeter. How would you find the volume?
um, 1 by 1 by 1.
Exactly, 1 centimeter by 1 centimeter by 1 centimeter. And you're done with 1 centimeter cube.
Yes, sir.
Right, so if it's volume, then the unit is centimeter cube. So my
Oh,
units are going to be centimeter cube per what? It's with respect to time, so that's going to be per what?
per second.
Exactly, because in question, that's what we measured time with respect to. So another
Okay.
way you could write that is 450 pi centimeter cube s to what power? Tell me guys, s to what power?
-1.
Right, s to the power -1. Are you okay with that?
Yes, sir.
Yes, sir.
Yes, sir.
Right, so that was the question. And let me just show you all the simulation. Y'all are gonna be mind blown. I think. Who knows? We'll see. Will you all be mind blown? Well, we will see. Check this out. Oh, you see my screen?
Yes, sir.
Yes, sir.
Check this badness, right? 4. So you're seeing, right? Like as time passes by, the height is increasing, the radius is remaining the same, and you have all of the rates over here. And the answer is for 55 centimeter cube per second. Yeah.
Yes, sir.
So Kamaya, for every second that passes, my volume increases by what? By how much?
Hmm?
Let me see if you
Can
really
you
understand.
please?
Let me see if you really understand it, right? So guys, this is our open-ended question. For every second that passes by, how much is my volume increasing by?
455.
Yes, 455. Kamaya, we found dVdt. What does dVdt tell us, Kamaya?
The volume with respect to time.
Exactly. So every second that passes by, how much does my volume increase by?
455.
Exactly, because it's 455 centimeters cube per second. You understand?
Yeah. Yes, sir.
Yeah. A little thing is cool.
Yes, sir.
Yeah, like Claude make this in a couple of seconds. Claude is insane. You should use Claude as opposed to ChatGPT. Claude is much better.
I agree, but Claude does take very long.
It's better though. It's better. Okay, so Jenna, here's what. I want you to explain the whole thing to me.
Oh, by the way, so yeah, it's not very real bad.
Let's say that again.
Your Wi-Fi, like, bad.
You
Not real bad, but
I checking my Wi-Fi speeds. My Wi-Fi speed's fine. Like it's not that bad. Like it's definitely lower than usual, but it's not insanely bad.
yeah, you're just breaking up, like, here and there, but not that.
Oh, actually, this is pretty bad. I don't know why amply I'm moving, so I would have to restart the router or something. Yeah. You're hearing me though? Let me know if you guys hearing me.
Huh?
You're hearing me?
Yes, sir. We hearing. Just bring up. Yeah, we hearing.
It was delayed, but yeah, you can.
Sound check 1 1. Sound check
Good
1 1.
night.
Rajiv to it. Oh
Good
yeah.
night.
Good night. What do you mean good night? What do you mean good night?
Good night.
What does come on, I mean by good night. Are they hearing me though, right?
I just say good night. Yes, sir.
All right. So Jenna, I put you on the spot. I want you to explain the whole thing to me. Go.
Okay, so the question was that the height of the water increases at a rate of 2 centimeters per second. So
Mm-hmm.
that tells us the change in height with respect to time, so dH dt.
Mm-hmm.
And then they want us to find the rate of increase of the volume of water. So that would be the change in of time with respect to volume. So that's
Whoa.
dV dt.
Whoa. Whoa. You say change in time with respect to volume.
I mean, sorry, change in volume with respect to time, my bad.
Right.
dV dt. So to find dV dt, is dV dH multiplied by dH dt. Yeah. And to find dV dH, you just like kind of differentiate the volume of the cylinder, which
With
was
respect
225
with respect to what? You're differentiating it with respect to what?
with respect to volume. I mean height, sorry, height.
Oh, yeah, with respect to
Yeah.
height.
Sorry. And then yeah, to find dV dt, you just multiply the 225 pi by 2, because that's what they gave us for dH dt, and you'll get 450 pi centimeters cubes per second.
Yeah. And what does this tell us? Tell me, what does this tell us?
The change in volume with respect to time.
Okay, so every second that goes by, what does that mean?
Every second that goes by, it increases in 450 pi
Centimeter cube.
centimeter cube. Okay.
Yeah, so every second that goes by, Jenna, the volume gonna increase by 450 pi. That's what
Okay.
dV/dt means. The change in volume with respect to time. So telling us how the volume changing with respect to time.
Okay. Yes, sir.
I understand that. You guys, until I know the meme where it's like, do you understand the word that coming out of my mouth? You know what I mean?
Yes.
That's it. That's how I just feel. How to make a video about that. I'm posted. It's how I just feel the whole class. I just feel like this, guys. I
So
just,
sometimes you do and sometimes you don't.
I just feel like as we feeling like Tucker. Let me try to impersonate Tucker. Do you understand the words that are coming out of my mouth? I can't do it. I feel like Nathaniel could do a better job than me.
I don't think so.
Give it a try.
Do you understand the words that are coming out of my mouth?
That was much better. That was much better. That was definitely much better. I could have swear that we had Tucker in class just now.
Yeah, that is nah, that was me. That was stuck in.
Must be.
Mm.
So I'm gonna give you that question. I want you to do it for yourself. Good notes, why maybe even so, way. Wash, man.
So you need to stop using good notes. We've been through this already.
Yeah, but I have like thousands of notes in this. I kind of locked in.
So
I
you
don't have a
need to
choice.
find a way to move from there.
It's like an abusive relationship, ends.
Mm-hmm.
Okay, go ahead, guys. Okay, are you all getting through?
No, sir.
How come?
No, sir.
How come, guys?
Because they're asking for the rate that the radius increasing, and I don't really know. To find that using the topic of what is called connected rate of change, right? I
Yeah.
I the radius increasing, I would think would be like dRdt,
Yeah,
but not
PRDT.
yeah, but nothing else really have dr, like nothing else really involved in radius. So I don't know how to.
There are plenty of things that involve here what? Nathaniel, I'll do the question. I promise it's real easy. How much I bet it's real easy?
Okay.
I promise. So like you have a spherical balloon, right? And
Yeah,
it's being filled with air. So you have a balloon here.
yeah.
And it's being filled with air. So as time increases, what's gonna increase? Let's look at what's gonna increase.
The radius and the volume.
Right? So
Yeah,
the radius is gonna change with respect to time,
yeah,
and the volume is gonna change with respect to time. You understand?
yeah.
And also something you mightn't see is the volume would change with respect to the radius.
Okay.
Think about it. As the radius increases, what happens to the volume of the balloon?
The volume will also increase.
Right. So these are the three rates that changing you're gonna consider.
Okay. Because we have the VDT already.
Nice. So any question they gave us volume, right? They told us volume is equal to 4 over 3 pi r cubed. Using this, we could find for what? If you had to say.
The radius.
No. What rate of change you could come up with using this?
Oh, yeah, the VDT.
No, not the VDT card.
Um,
They still have time in it.
okay.
What's the variable in this?
The variable
Yeah.
R.
R. So you could, if you differentiate this, you'll have to differentiate it like what? It'd be what over what?
This would be the VDR.
Exactly, the VDR. You know, maybe we should find this one time. If I do that, what would I get?
It would be 4/3 pi. Or that's no. It would be hmm.
So remember, when you differentiate and you multiply by the power,
Yeah. So it would be 3/4 pi R squared.
right? What's 3 by 4 over 3?
That would be that's no 4.
All right, so that'll be 4 pi r squared.
Yeah.
You with me?
Yeah, I would say.
And they're telling us it's being filled with air at a rate of 200 centimeters cube per second. Now, here what? This isn't, they're not telling you explicitly, right? But you could look at the units to figure out what rate of change this is. Look at the units. You see in centimeter cube per second.
Yeah.
What do you measure in centimeter cube?
I guess in this case, the volume,
Right? And what do you measure with respect to seconds?
time.
Right. So they gave you dVdt.
Yeah.
So well, we know that dVdt is equal to what?
200.
Yeah. So I'm gonna put that dVdt is equal to 200 centimeter cube per second.
Yeah.
And we know what dVdr is, right?
Yeah.
Go easy, right? Check this out. Calculate in terms of pi.
And then put the cube.
We mean I didn't put the cube.
By 200 centimeters.
Oh yeah. Right.
Also, why you keep putting out that by the
I just
thing?
listen it. I just listen it. You know how to part that.
Okay.
I just write it like a list, you know? Got bullets.
Okay.
I remove it to probably feeling weird about it.
No, it's fine. I was just asking.
So Nathaniel, let's say calculate in terms of pi the rate at which the radius is increasing. So they want me to find what?
DRDT.
They want me to find the RDT.
Yeah.
So let me show you how we're gonna go about doing that, right? So they want we to find dRdt.
So this is kind of where I would get stuck because yeah.
All right, check it out, right? If you want to get dRdt, you're gonna multiply two different rates of change.
Yeah.
We're gonna come here for sure.
D dr
We're gonna come here for sure.
dr
No, we already have the R. We're gonna come here.
dt.
Yeah, dt gonna come here.
Yeah.
And Nathaniel, here we're gonna ask you, right? Radius and time. Are there any other parameters that we could put here and here so you can cancel off?
Volume.
Exactly. So this will be dV and this would be dV. You understand?
Yeah.
So my question is, what would dRdV be, boy? Tell me, Nathaniel, what would that be?
dr dv.
Yeah. What do we have that looks like that?
We have dvdr.
So we think dRdV could be then.
Just the reciprocal dvdr.
Yeah, so that'll just be 1 over what?
Just now.
You're overthinking it. Okay.
No, I know it's 1 over dvdr. But
Right.
yeah. What that was again?
dVdr was 4 pi r squared.
Right. Okay, yeah. I was just looking for it in the word, yeah. So it's 1 over 4 pi r squared.
Right? And so we can put on now. So it's gonna be 1 over 4 pi r squared.
It's a how one?
Say that again, Jenna.
How is it one?
So 4 pi r squared is the same thing as 4 pi r squared over 1. So if I were to flip both sides, it would be 1 over 4 pi r squared.
Okay.
Think about it like this. Like if I write 5, right? 5 is the same thing as 5 over 1.
Yes, sir.
If I flip that, I'll be 1 over 5. Same logic go by.
Okay.
So it's going to be 1 over 4 pi r squared multiplied by dv dt. What did it give us dv dt as? Tell me, guys, what was dv dt?
200 the cube.
200.
Right, 200. 1 by 200 is 200 over 4 pi r squared. Now, if you observe something, they said when the radius is what? When the radius is...
10.
So what we're going to plug in for r?
10.
Yep, we're going to plug in 10. So that's going to be 200. And in the denominator, you have 4 pi by 10 squared. 10 squared is what? What's 10 squared?
100.
And 4 by 100 is 400. So you're going to put 200 over 400 pi, which simplifies to a half pi. Well, sorry, 1 over 2 pi. Let me know if you guys understand that. Because like 2 over 4 is 2 over 4, guys.
A half.
Right, so 1 over 2 pi. We need to put the units. So Nathaniel, the units are it's radius over time, right? So what's the units for radius?
Centimeter.
So it's gonna be centimeter.
This
All right, so Jenna, talk to me. If there's anything here you didn't fully understand, let me know.
I think I understand, but like it's just I didn't know you could say dr over dt because I thought there was only like 3 like rates of change. But I understand.
Say that again.
I didn't know you could use dr like for radius because I thought there was only like 3 types of rates of change.
What do you
But
mean three types of rates of change.
Like how we did in the first question.
No, there ought to be three types of rates of change.
Okay.
So like I think the hardest part about this question, okay, so let's there's a algorithm you could follow for these type of questions, right? Let me teach you guys the algorithm. So when you read the question, there's a high chance they are going to give you a formula for volume, area, whatnot, right? They're going to do that. You write our formula down. All right, are you with me?
Yes, sir.
Yes, sir.
Right, so Jenna, Kamaya, Nathaniel, Sachin, Zachary, here's the trend, right? They will give you a formula for volume, area, or whatever. Write that formula down. At some point, you'll have to differentiate that. Remember that. Then they will give you a rate. And it'll be your job to figure out what rate is that. If I see 200 centimeter cube per second, Jenna, what do we measure in centimeter cube?
Volume.
And what do we measure in second?
Time.
Right, so that 200 centimeter cube per second, that's actually dVdt. So I'm gonna come here and I'm gonna put that down. So I was given dVdt, I was given the formula for volume, cool. And now I'm going to look to see what they ask. What are they asking me to find, Jenna?
The rate at which the radius is increasing. So dr/dt.
dRdt, yes, dRdt. So I'm gonna put that down here, right? So dRdt. So Jenna, let's think now. Jenna, if I want to get dRdt, then I must have dr over here, and I must have dt over here. Some of you following?
Yes, sir.
Good. Now, whatever I put here and here, it must be the same so it get cancelled off.
Okay.
Does that mean, like, they say okay, right? But let me know if that
Yeah.
makes sense.
Yeah, that makes sense.
Because if it cancels off, it leaves you with what?
dr/dt.
Exactly. Leaves you with dr dt.
Yes, sir.
Cool. And you want to know how I figure out that the other variable is volume?
Yeah.
Look
Yeah.
at the bigger picture, right? Look at the bigger picture. You have dr dt, right? So you see in radius and time. What formula they give you?
4/3 pi r.
But what does that
Cube.
represent? What does that represent? That's the formula for what?
A sphere.
No, for what? What of
Oh,
this?
for the spherical balloon.
No, for what of the balloon? For what of the sphere?
The volume.
Area, the volume. So, Jenna, like here's how I think it, right? Radius and time, cool. That's two parameters. The only other parameter mentioned in the question is what?
Is dv. Oh,
So I put dv here and I put dv here because that's the only other thing they mentioned, right?
yeah.
So now I thinking, well, okay, I have dv dt, that's 200. Cool. I don't have the RDV. I need to find for it.
Okay.
So I'm looking at the formula here. What's the variable in that formula? What's the variable?
Radius r.
R. So we can differentiate volume with respect to the variable R. If you do that, you're going to get 4 pi r squared. How? Well, when you differentiate, you multiply by the power. So Jenna, you multiply by 3. What's 3 by 4 over 3?
3. I mean, 4, sorry.
4. So you're going to get 4 pi r squared because you take away 1 from the power. So 4 pi r squared. So that's 4 pi r squared over 1. But in the question though, you have to find dRdV. A way to make the connection that dRdV just the reciprocal of this. That's all.
Okay.
You see now,
Okay.
like look, it's just the reciprocal. That's all.
Yes, sir.
So you just flip it. So dRdV is 1 over 4 pi r squared. And in the question, they said when the radius is what? When the radius of the balloon
Is increasing. Wait. It's 10 centimeters, sorry.
10 centimeters. Right. So we're going to replace the radius with 10 centimeters. And yeah, you get the answer. Simplify from there.
Yes, sir.
So long story short, here's the trick. Look for any formula they give you. Just know you got to differentiate at some point, right? They gave us volume. We might have to differentiate volume. Cool. Then you're looking for any pieces of information. Write that down. Then you're looking for where you want to find. If I'm trying to find dRdt, I'm gonna put dr here and I'm gonna put dt over here. Then I'm looking for another parameter. I see that volume is mentioned, so I'm gonna use volume. dv, cool. I have dv dt. Nice. I had to find drdv. Notice that I just use reciprocal of dv dr. So you just differentiate and you reciprocate it. And the last thing you're looking for any pieces of information they're specifying. They're saying when the radius is 10. So you had to plug in R for 10. And here you get your answer. So I think I need another question like this. What do you think?
Yes, sir.
I think so. Mazaka. How much of you guys think or like get the idea?
Yes, I think so.
Yeah, I get it. I get.
So like
Yes, sir.
once they tell you what to find, you're gonna put that down. You're gonna put whatever they tell you. Okay, so like look, if they tell you to find dRdt, dr going on top, dt going in the bottom. Then you just had to figure out what other parameter it have. The other parameter it have is v. So dv. Now it's just up to you to find what the RDV is. So I come up with a question for you all. Now, second. Aha! Nice man. I have a nice question for you all. Yeah. So it's I'll just say I'll get it by now, right? So let me see if you really get it. How much of you guys think understanding is learning? If you guys think that?
Yes, sir.
I
I
think so.
I don't think so. Until them all they understand it a million times. But can you answer the question and get correct 100% of the time? That's the question. Can you guarantee that? The answer is no,
Probably
right?
not.
Okay, like real learning comes from understanding and doing. That is what real learning is like. You have to understand and then you have to do. Yeah, saying you understand is not enough. You have to do. I just see that myself. Like I go say I understand something, and when I have to do it in the exam, is like, wait, shucks. So understand and then practice. So give this question a try. Okay, y'all getting through?
Yes, sir.
All right. Jenna, Kamaya, Sachin, Zachary, let me know what's going on.
Yes.
Jenna, talk to me. All
Kind of.
right, so Jenna, we'll do the
Yeah.
question together, but I'm gonna give you all 3 more minutes, then we'll do it.
Uh,
So as soon as you have an answer, you let me know. Okay, did any of y'all get through? I want to at least see one person get through.
So I almost did.
All right.
So I think I get it. I'm not sure, Sunny.
All right, let me check. You make a little mistake. Very small mistake, Sachin. What happened to the pi in the denominator? Yeah. So I'm Sachin. What happened to the pi in the denominator?
I forget it. I forget it.
Yeah, that's the only mistake in me. Good job, good job. Yeah. Just imagine doing the right thing and getting the question wrong because of that. Sachin, boy. Be careful. I would hate for you to lose marks because of something like that.
So I'm gonna send it to you, but I kind of scrap.
That's okay. Let me see. Zachary, one thing though, Zachary, that one's I could simplify enough. I could simplify.
Okay, so hold on.
Zachary, where's 96 over 24?
Yeah, 4, so
Right? So where's the final answer?
this is 4 centimeters per second.
If again, so you're making the same mistakes as you make. Yeah, gotta be careful. In the denominator, what you have? What do you have in the denominator?
Pi,
Right, so was it say back your answer then?
4 centimeters.
No. Yeah,
Four,
I don't want to tell you the answer. I want you to tell me for yourself. Yeah, 4. Mm-hmm. You're going good.
4 pi centimeters per second.
No, it's not 4 pi. That pi is only what? Where's that? Where's pi?
In the denominator.
Exactly. So say back.
I'm not too sure.
Yeah, exactly.
Oh, oh. All right.
Yeah. Ah. Yeah. 24 into 96 is 4 over pi. That's the answer you're supposed to get. You tell them a 4 pi. Ah. Right. So guys, if you didn't get 4 over pi, your answer is wrong. There's some reconsidering you might need to do. Right? 4 over pi is the answer you're looking for.
4 over pi.
Yeah.
Uh, all right.
Yeah.
So you will end up with 16 over 4 pi, and then that becomes 4 over pi.
Well, if you get 16 over 4, sure. Yeah, that's correct.
All right. Yeah, okay.
So you can leave it as the 96 over pi 24.
Yeah.
Why would you do that?
I know, like, I didn't want to do that, but like,
I think about it, right? If you finish that question in maths and you end up with 10 over 2, would you leave it as 10 over 2?
Nah, so
no.
Yeah, exactly. That's my point. You will
simple
simplify it.
math. You will lose marks if you don't simplify.
Yeah, you lose on math.
All right, so
In most of the instances, they would say as simple, like they expect you to simplify it as much as possible. They're expecting that. All right, so Kamaya, I see say never mind, exclamation mark.
Never mind.
So my working real scrappy, but still selling it.
All right. Jenna, talk to me. Let me know what's going on.
I kind of stuck, honestly.
All right. Which part again you suck?
Um, Honestly, I'm not sure. Yeah, I'm not sure. I don't know. I just stuck.
Where did you reach?
Well, I was gonna start to differentiate the formula.
Did you analyze the question first to see so my advice is you analyze the question, you see what they give you see what you're trying to find, and you see any formulas they give you. That's my advice. So let's do that. Let's take that strategy. So Jenna, um, what shape we dealing with first? That's what I'm gonna ask you. What shape we dealing with?
Cylinder.
All right, we're dealing
But
with a cylinder. So you okay with that? We have a cylinder,
yes, sir.
and it has a fixed thickness of 4 centimeters. So I have a question. In the formula for volume of a cylinder, what dimension would thickness correspond to? Would it correspond to radius or height?
Height?
Height, cool. So this is the height. Now, in physics, right? I'm not sure if you guys would have learned this, but in physics, when you heat a metal, it expands. Did you learn about thermal expansion?
No, sir.
Did anybody learn about that? Thermal expansion?
No, sir.
No? Did you learn about the kinetic theory of matter?
No, sir.
Yes, we did.
So, like, when you heat up metals, or literally anything, okay, especially metals, right? Because metals have free electrons. When you heat metal, the electrons, they gain energy, and they start to vibrate more. And if it starts to vibrate more, it's gonna exert more pressure on the outer surface. Oh, sorry, the inner surface, and it'll push, and it will eventually expand. Let me explain it in a better way. When you heat something, the molecules inside, they gain kinetic energy. And if they gain kinetic energy, they're gonna want to start to vibrate and move about. Right? So, Nathaniel, if you get energy and you start to move about, and you would want to like go all over the place.
Yes, sir.
But like if it's a fixed volume, and you would want to push against it push against it push against the surface to expand. Like, okay, think of this. If you have a water bottle and you squeeze the water bottle, what happens to the volume? Like what happens, Nathaniel? Like if you have a water bottle, empty water bottle, and you squeeze it, what happens?
The water will come out.
Yo,
Oh, the volume would if you have an empty water bottle and you squeeze it, wouldn't the volume decrease?
the volume would decrease and the pressure
Yeah.
would increase, right?
Yeah.
Okay, it's a similar kind of concept. So if you heat the metal, the molecules inside are gonna gain kinetic energy, and they're going to start to move about violently, and they're gonna collide with the outer, they're gonna collide with the inner surface a lot more. So they're gonna start to push against the walls of the metal. And if that is the case, and what would happen to the volume? Would the volume remain the same or would they want to expand?
Would want to expand.
Exactly, because you have molecules now that have kinetic energy that wants to move about, and they just pushing against the wall of the metal, and that will cause it to expand. Yeah. But anyways, let's get back on track, right? So Jenna, we have a cylindrical metal disc, and the height is 4. Right?
Yes, sir.
Okay. And they're saying that it expands outwards. So if it expands outwards, what will change? What's changing?
The volume?
Or the volume would change, but what would change as well? If it expands outwards. So it's expanding outwards. You know what that means?
Or the radius?
The radius, yes. If it expands outwards, then it's going to, the radius is going to increase. I mean, if you catch that.
Yes, sir.
So its radius increasing while the thickness remains the same. So Jenna, we are seeing here that the radius changing, right?
Yes, sir.
Does the height change?
No.
Because they say the thickness stays the same, right? Cool.
Yeah.
They're telling us the volume of the cylinder is pi r squared h. So volume is equal to pi r squared h. Now, Jenna, which one remains constant again?
The radius.
You sure the
No.
radius?
No, not the
It's
radius.
constant.
The height.
The height. Remember, they're saying its radius increasing, the thickness stays the same. If
Yes,
the
sir.
thickness stays the same, which quantity here is actually a constant?
The height.
Exactly. So here what? We could actually plug in what the height is. What is the height?
4 centimeters.
Right. So volume now becomes 4 pi r squared. You with me?
Yes, sir.
Right. So we have that formula for volume. Keep that in the back of your head. And furthermore, Jenna, what's the only thing you could differentiate that with respect to? What's the only thing you could differentiate that with respect to?
this with respect to volume. I mean, sorry, height.
No, but height is a constant. You can't differentiate it with respect to height.
Oh,
What's the variable here?
or radius. With respect to radius.
Exactly. So you're going to differentiate volume with respect to radius because that's the only variable they have. So maybe you might have to find dVdr, right? Hold that thought. Then they're saying the volume of the disk is increasing at a rate of 96 centimeter cube per second. So what rate of change is that?
That's dV/dt.
Right? That is dV/dt. So they're giving us dV/dt, and that is 96 centimeter cube per second. All right?
Yes, sir.
Then they're saying calculate in terms of pi. Sachin and Zachary. If they're saying in terms of pi, can you just casually leave out pi? Sachin and Zachary.
No,
You know how to
sir.
dig no horrors. Because I don't want to make that mistake in the exam. Sachin, if they say in terms of pi, right? You can't leave out pi in your final answer.
See, I just slipped my mind now. Forget about it.
Well, I'm telling you this, so it wouldn't slip in mind next time. Right? So they say calculate in terms of pi. So your final answer must have pi, whatever you do. So Jenna, they want me to calculate the rate at which the radius is increasing. So that'll be what? What do you want me to find?
Um, dV/dr.
Say back again. Rate at which the radius is
Increasing
right. So what changing with respect to what there?
the vol time
What changing with
so
respect to time?
the radius. So dr/dt.
Yes. Here what, Jenna, anytime you see the word rate, anytime you see that word, just know you're dealing with respect to time. And
Okay.
the next thing you see in here is radius. So that means the radius is changing with respect to time. You with
Yes,
me?
yes, sir.
So Jenna, what you want to find for?
dr/dt.
Right, so I'm gonna put that over here because we want to find for the RDT. Now to find for the RDT, let's do a checklist, right? If I want to find for that, we have to multiply two different rates of change. What should go on top here for sure?
dt
Nah.
or dr.
How come you say DT? Talk to me.
Um, I don't know.
Before you tell me something, I want to think about it, right? Think about it logically. If I put DT over here, that don't make sense because we want DT to be in the denominator,
Yes, sir.
right? So what would I put here?
dr
What would I put here?
dt.
And here what? Now we're looking for another parameter. What other parameter we could use?
dV.
And as a matter of fact, like this is really telling you, like watch. And you have DVDT,
Yes, sir.
so it makes sense for you to use DV.
Okay.
So, Jenna, we have DVDT, right?
Yes, sir.
But we had to find the RDV. How could I find the RDV?
Differentiate the volume
Differentiate the volume with respect to what?
with respect to the
What's the only thing you could differentiate with respect to?
radius.
Right, remember, Jenna, you can't differentiate with respect to height because height in this case is in this case, height is
It's
a
constant. The constant.
yeah, so you can't differentiate that. So the only thing you could really do is differentiate volume with respect to radius. And that will be what?
Um, 8 pi r 8 pi r.
Right? Wait, give me a second. Yeah, that would be 8 pi r. You guys with me? I mean, if you guys with me.
Oh, I thought it was just 8 pi.
No, 2 by 4 is 8. And then you minus 1 from the power. 2 minus 1 is 1.
But yeah, when you differentiating in terms of R, oh, never mind. I understand.
So you understand, I'll multiply by 2, and then I'll take away 1 from the power. So 2 minus 1 is 1, so that's just 8 pi r.
Yes, sir.
How about the rest of you guys? Do you all understand?
Yes, sir.
Yes, sir.
Okay, cool. Nice. So we have 8 pi r. But, Jenna, we want to find dRdV. So how could I find dRdV?
So now you multiply the dRdV by dV/dt.
No. So I have dRdV, right? Well, sorry. We want to find dRdV, right? But right now I have dVdr. How am I going to use dVdr to find for dRdV?
Yeah, well, you'll say if a bit, so 1 over 8 pi r.
Yep, 1 over 8 pi r. Are you understand that or no?
Yes, sir.
Right, so that would now be 1 over 8 pi r multiplied by dV/dt. What is dV/dt again, guys?
96.
96. Now remind me, in the question, well, they said when the radius is 3 centimeters, right? When the radius is 3 centimeters. When the radius is 3 centimeters. So 1 by 96 is 96. And that's going to be 8 pi by what, Jenna? What's that going to be? 8 pi by what?
3.
Yep. And 8 by 3 is 24. Now we could simplify this. Jenna, how much times 24 going to 96?
4.
Right. So your final answer is
4 over pi.
right. 4 over pi, fellas. 4 over pi. And it's radius over time. So, Jenna, what would the units be?
dRdt.
That's not, that wouldn't be the units now.
Oh, sorry, centimeters cube.
Nah. Okay, what would we measure radius in? Radius.
Squared. Squared.
Nah. Well, how come I say in squared?
Or radius.
How would you measure radius?
Wait.
Here's a way to think about it, right? If you're measuring radius, right? Is radius okay? Is radius okay? Radius is that 1 dimension, 2 dimension, 3 dimensions? What's that?
Oh, 1, because it's a constant.
It's just 1 dimension, right? Radius is 1 dimension,
Yeah.
right? Because then you measure in a straight line radius,
Yes, sir.
so that'll be centimeters.
Oh,
If it was area is 2 dimensions, so that'll be centimeters squared. If it's volume, that'll be 3 dimensions, so that'll be centimeter cube. But
oh,
radius is just in a straight line. Radius is just centimeter.
okay.
So
Yes,
radius is centimeters, and so it'll be centimeter per what?
per second.
Right, centimeter per second. So you can say centimeter per second like this, or you could write what? Or you could write
As to power -1.
yeah, that's it.
So I think the back has sleep getting to John.
I think
See
so.
why you need to sleep, guys.
Yeah. Jenna, I think the lack of sleep really get into you.
Yes, sir.
But it's fine, it's fine. I don't mind explaining. But definitely I think it's the lack of sleep. So I'm gonna end class a bit early. I think Jenna needs some sleep. But I'm gonna make a worksheet right now for you guys. So you all could practice rates of change. How
So
much
that would
questions?
be very much appreciated.
And I'll put the answers one time, so all you're gonna know if they're wrong.
Okay.
All right? It's only if you can't get through at all, then message me. But the answer's there. Yeah, I feel like you all could work towards it.
Nice.
How much questions are they want?
3.
100.
5.
Five, I'll do five. Can you make a one moment? Let's just give the AI some time to generate. Like this is a thing, eh? Like this goes on bad as a lessons teacher. I find like actually that's a lie. Like, yeah, even though you have AI and thing and you could study for yourself, it's good to have somebody to explain it to you. Yeah, I understand.
Yeah.
I genuinely feel like if I was like in UE, if I had somebody like a mentor, that'd be really good. Yeah.
I don't know why university children don't get sense.
When I
And
graduate,
nobody wants to teach the UV. But
because it don't really have much profit in that, you see. Like what people wouldn't tell you is like lessons is a highly profitable thing, like I just be cutting it kind of close into that profit. Like I doing this for you, I doing this for the children. I love to help people, but most people is like just money. It's like it's just about money. So it's like if it's not profitable, they wouldn't do it. Like I'm telling you, it's crazy. When I see like how the world is work, it's like crazy. Everything is just about money. It's crazy. It's crazy. That's why you need to like keep your inner child. You need to like remember that there's things other than money, you know. But yeah, there's and like the university just like come down on you too. Like if you're doing lessons, the university go want some of that money and all kind of thing. Real crazy.
what?
Yeah. You get into trouble and
That's
thing.
a bit much.
Yeah, I tell you, everything is about money. It's ridiculous. Like I feel like certain things like education and like health and these kind of things, you shouldn't have to pay for them thing, man. Come on. I feel like these are like basic things in life you should get. You know what I mean?
So then how people gonna live the government supposed to be educated? Well, that's no I mean like in America. That's how they pay for education. Like
Let's do that
how
again.
else will they get paid? If everything free, how do people delivering the services gonna get paid? Because
Uh,
government
well,
and the government pay everybody.
well, in a lot of communist states, the education and healthcare and whatnot is free. It's paid by the tax. So like
Yeah.
it's not entirely free, but in a sense it's free. You understand what I mean?
Mhm.
It's like a hidden cost. But I find that's fine, like a hidden cost, like everybody pay tax and the taxes put to good use. That makes sense.
But when they have to pay more,
Actually, in those states where there's like a lot of people and the GDP is higher and the general way of life, like you gotta understand, Kamaya, like the way we live in Trinidad is crazy, you know. You know how much people is like live like on paycheck to paycheck and it's like below yeah, like okay, if you compare like Trinidad to like the UK or Canada, like it's very different.
yeah,
So the average person in Trinidad makes like around 5,000 to 4,000 TT dollars, which is like insane. That's very, really, really low.
that's low.
That
Okay.
that is very low. Like
Oh,
when you look at rent, when you look at bills, like that's nothing. It's like that's like
oh. Well, nah, my parents way below that.
Yeah, like um so when you think about when you think about the argument, right? In other developed states, first okay, in those countries that have billionaires and thing, like several billionaires, millionaires, that these are places that have like they have a lot more finance. You understand what I'm trying to say?
Yeah.
Comparing that to
Yeah.
Trinidad. So it's a bit easier to provide free services like that, where it's paid through
Yeah.
tax. I think like in China, when you make a child, they just give you like money and like supplies and whatnot to take care of the child. I think so.
Yeah.
Like in Japan too, like in Korea, South Korea. Um,
Yeah.
in the US, if you want to have a baby, it's like 30,000, 18,000, I mean 18,000 US dollars. I'm not kind of shipping this.
Hmm.
All if I not make sense, like to give birth to a child, you ought to pay like 18,000 US. What?
Nah. That's
That child will
that's
stay right
alright.
there. I don't want no children. That's the case though. Nah, not me on that. That's crazy, boy. So I'm giving you all a question. The answers are already there. The answers are already there, right? I trust that you all are big people, and you will look at the answers only if you're dying, and you can't really
Yes, sir.
figure out anything. One second. I'll want me to send it separately or just put it in in the same document.
That was done the same thing.
But, so come on, you say your parents make below 5,000?
Yeah, I think so.
Um, if you need help on thing, you'll let me know, right? Like, I know it's like nah, because like
Hmm.
I live in a similar like environment, like at home, like I'm the only one really making money.
Yeah,
Like,
that's how I'm trying to be. Like trying to get out of the poverty.
yeah,
Don't get me wrong, me nuts. I still thankful for everything I have and I get to go. I traveled to New York like last year and that was like the first
what?
time. So I'm grateful
Bro,
for that.
yeah, what?
So.
How do that
Though
make sense?
like
How do that make sense?
maybe how that makes sense.
I never even see New York. Like, I never traveled in my life. I
So we make it with my aunt does live in New York, so we stayed by her and then like expenses. They had to like forget us on YouTube, but like they had to take us out and then like things just happen.
oh, I see.
Yeah.
All right. Well, I give you all some questions, so like I warm up, I build in, then like stepping up, then challenge, then exam beast. Like cool. And I have the full answer key, everything over here. So you don't need me. You only need me if like you're really lost and you can't figure out anything. Right? And if you all want, of course, I could go on our live and we could correct this so it wouldn't take away from class time.
Okay.
The next thing, okay, so we essentially done with differentiation then. Like we done. We done with differentiation. Yeah, we're done.
Wait, so I have a question. The differentiation homework questions that you gave us from the week before last week. I don't think you corrected it. So
Uh, you sure?
yeah, I think last week you said you would do it on a live and then it didn't end up happening.
All
I'm
these
not sure.
questions.
Yeah.
Yeah, I want to do this on a live. So like we could come on, we could just do some odd maths.
Okay.
What's a good day? That would follow you. But it's when I'm free too. Um, Tuesday is the only day that makes sense for me. But like Jenna, I say I can't make Tuesday
Well, no, it depends on the time.
because I wanted to do that during the day, probably like start, well, not really during the day, but like start 7 o'clock and go to like probably like
Okay.
7 p.m. In the night.
Oh, yeah. That should be, yeah, that should be fine.
Guys, if you want to become hard maths beasts, you gotta put any work, eh? Hard maths is something that require a lot of work. Yeah. And I willing to help all, like if all everybody help, I hear, I hear. But I had to pay any work. Yeah.
Yes, sir.
Right. So guys, oh by the way, make sure and tell your friends about the classes on now. I want to like at least have this class at 15. I feel like we can make that. I feel like we could do that, 15 students. I think we could do that. Um, I feel like the max amount of students I want to have for this class is probably 25. 25 is the max. I don't want to have more students. For a class like AdMaths, where they explain, 25 is like a good number. So, Ollie, share the flyer and thing, please. Get your boy off the streets. I want to buy a Casio. I want to buy a Casio calculators, but I can't do that if I broke. So,
Alright, see.
yeah, so like share the flyer and thing you don't know, right? But yeah, do the homework and send it to me. The answer's
So
there.
you need students for your math class?
Yeah, yeah, and I always take in incidents. Like the limit for the maths class is 50. Right now we had like 23.
Alright.
Yes, sir, we could advertise now. They say the physics, not the maths. Could advertise it.
Well,
But
you
hard
wanna
maths, they have to keep you on lock.
what? What do you mean? Like, I don't understand. Like that's like keeping me. I know what they're saying, right? Like, I wanna like keep my like niche, like it's like our class is like I know, but like I had to make a living. Yeah, and I'll still give all that attention. Like, I don't think I'll have to worry on yourself. So appreciate you all. Spread the word. But yeah, guys, I'm gonna send out
Okay,
even note
sure.
something now. I'll have a blessed evening, a blessed day. Take care.
Yes, sir, bye.